I am Kashish Vazirani from EL6303 and today I'm going to discuss in this video question 1 of homework 2, and this is my name again and this is my NID. So the question says, given f of x is equal to a 1 minus e raised to minus bx u of x minus a, where u of x is a step function, a and b are positive constants, find a so that f of x is a probability distribution function. So f of x, given here u of x is a unit step function, and we need to find a given that f of x is a PDF, a probability distribution function. Now, what we need to know about probability distribution functions is that the integration of a PDF will always be equal to 1. So this is what we have to keep in mind. Moving ahead, we also have to keep in mind that the probability distribution function at infinity is equal to 1. So keep this in mind too. And now we have u of x minus a. U of x minus a is basically a unit step function, so it will look something like this being a, this being the x-axis, this being 1, and this is u of x minus a. So this is what a unit step function will look like. Therefore, our limits will go from a to infinity. And at infinity, we know that the probability distribution function is equal to 1. So on integrating from 0 to infinity, we get a into e raised to minus bx divided by b plus x. 0 to infinity is equal to 1. Since at infinity it's going to be equal to 1, all we get here is the constant a into 1 minus a into e raised to minus b raised to a. a into 1 minus a into e raised to minus ba divided by a plus 1 is equal to 1. And on opening the brackets, this is what we will get. Hence, a is a constant, which is equal to b divided by a plus b minus e raised to minus ab. So this was the first part of question 1. Moving on to the second part, which is draw f of x. Let's see. So draw f of x, that is draw the PDF. Now we know f of x is equal to a into 1 minus e raised to minus bx u of x minus a. This is how u of x minus a looks. This is how e raised to minus bx will look. 1 can be considered as a unit step function. So we'll have an intermediate step. So basically this minus this into this will give you this. So you did this multiplied by this, which gave you this. Everything between 0 to a will be 0, and everything between a to infinity will be 1 multiplied by this point here, 1 multiplied by this point here, which will basically give you something like this, starting from a, assuming that a is greater than 1. Now, we still haven't done anything about this. So treating this as a unit step function minus this will basically give you 1 minus 0, which is equal to 1. 1 minus 0, which is equal to 1. Therefore, this will be 1 until a, and then 1 minus this value will give you another value, which will basically be decreasing from 1. Therefore, this is how our probability distribution function will look. Moving to the third part of the problem, find and draw f of x. This time our f of x is another PDF, which is basically the density function. To find the density function from the distribution function, we have to take the derivative of the distribution function. on taking the derivative of a into 1 minus e raised to minus bx u of x minus a. I haven't shown the steps here, but this is what we'll get. U dash of x minus a is basically the derivative of a step function, and derivative of a step function when taken and drawn is basically a delta function. I haven't been able to find how exactly f of x will look, but I know e raised to bx will look something like this, and u dash x minus a will have two delta functions, one at 0 and one at 8. Thank you for watching. I hope you understood.